Today we are going to start discussing iteration. But before we do that, let's make a method. Let's say I want to make a method called sum that asks the user for two numbers and then prints the sum of them. We're going to need a method signature. We need to get some input, and we're going to want to print the sum. Let's say we make the signature public static void sum so that I can just call sum no matter what. I don't need an object to call it. I'm going to get some input. I need to make my scanner variable. I'm going to ask for two numbers and save their values into two doubles. And we're going to print the sum is, and then the total of n1 plus n2. So that's pretty easy. We can all make a sum method. But what if I wanted to increase the number of numbers that I am requesting? What if I want, instead of asking for just two numbers, what if I wanted to ask for 5 numbers? What would I need to do to this method to accomplish that?
More lines, more variables.
I would need more lines and more variables. I would need to copy that input. Those two lines are not the ones that are paired. It should be this one and that one. But whatever. We would need to copy our prompt and our actual input line over and over, and we'd have to have a whole bunch of variables. And that also doesn't let us choose how many inputs we want. If I hard code 5 inputs, I can't only give 3 numbers and find the sum of that. I always have to give 5 at that point. So there's got to be a better way, just like there always has to be a better way, and there always is a better way, always. And we can avoid writing repetitive code by using a new control structure called the while loop. While loops allow us to repeat a block of code until a specific condition is met. So they have 3 pieces. They have the while keyword, which we can see here. They have a condition, just like an if statement. Condition needs to evaluate to a Boolean value, true or false. And then they have some body of code. Just like an if statement, the body of a while loop will run as long as the condition is true when we check it. Unlike an if statement, though, once the body has finished running, we're going to jump back up to the top and check the condition again. If the condition is true, we'll run the body again. And so on, until when we check the condition, it becomes false. So if we look at a flowchart of what this looks like, remember our if flowcharts. Before, we had our true, and then the body code would lead to the code after the loop. Now, our body code leads back to our condition. We will check the condition again. If it's true again, we'll run the body and then go back to the condition over and over until when we check the condition is false, leading us to the code after the loop. That makes sense so far? We can repeat code over and over again. All right. So as an example, let's say I want to make a program that just counts down. I've got an int countdown equal 3. Boom. I've got my countdown variable. My loop is going to check while countdown is greater than 0. So my current value in countdown is 3. Is 3 greater than 0? Sure is. So that's going to be true. So since my condition was true, we're going to enter our loop. We're going to print countdown. We're going to print 3. And then we're going to subtract 1 from countdown. Countdown is going to become 2. Now the body of my loop had finished. We're going to jump back up to the top and check our condition again. Is 2 greater than 0? Sure is. That is still true. So we're going to run our body again. We're going to print what countdown was. We're going to subtract 1. and we're going to jump back up to the top again. In 1 is also still greater than 0. We're going to run the body again. We'll print 1. Countdown is going to decrease. Then we're going to check our condition again, keeps happening. Is 0 greater than 0? No, it is not. So now our condition is false. We're going to skip the body, and we're going to run any code happening after the while loop. In this case, we're going to print countdown complete. So this is what our final output for that program would look like. And here's what the flowchart looks like when I've copied those lines of code into my flowchart rather than just having words. If the condition for my while loop is false the very first time I check it, the body of the while loop is just never going to happen. So if I initialize countdown to equal 0, countdown is not greater than 0 at the beginning. We're never going to run the body. We'll just print countdown complete. Something to be careful of is remembering that the line of code, whatever line of code we have that's changing our variable in the condition, it's going to be called our loop control variable because it's controlling whether the loop is going to end or not. This line of code changing that variable is very important because without it, my loop condition couldn't become false. If I don't decrease my countdown, countdown will always be 3, and 3 is always greater than 0, and that will make this loop forever and ever. So a loop that cannot end is called an infinite loop, and we really want to avoid making those. In general, let's avoid infinite loops because they will crash our programs. Computers do not like infinite loops. If we want to stop executing a loop halfway through its body, rather than at the end of the body when we jump up and check the condition again, we can use the break keyword. When a loop encounters the break keyword, it will instantly stop running. The rest of the body will not execute, and we'll just skip to after the loop. So it's usually best to include breaks inside of an if statement within your loop so that you don't just always exit the loop halfway through. Generally, also, if I have a loop that incorporates a break, we can usually remove the condition of that loop and just make it equal the Boolean value true. Because if I'm checking a condition inside of my loop, I'm usually not going to be, it's not going to matter if I check that same condition in my while loop, because checking it twice is kind of redundant. Both styles of loop, the one where we break in the middle and the one where we have our condition at the top, both are equally valid. They both work just as well. Some scenarios are just better for one or the other. So in this example, I've got my counter variable. I'm saying while true, and since this condition is true, this loop will keep looping forever and ever. Counter minus minus, I'm going to subtract 1 from my counter. If my counter is equal to 0, giving away my answer, if my counter is 0, then break. And after my if statement, I'm going to print my counter. So what values will be printed by this loop?
Five, four, three, two, one.
All right, very close. But if we look at our order here, counter starts at 5, and before we print, we're gonna subtract 1. So our first value is actually gonna be 4. Then we're gonna subtract to 3, 2, 1, and then when we loop back up to the top, we're gonna subtract 1. Counter will equal 0, so we'll break. and not print 0. So we will just see 4, 3, 2, and 1. So keeping track of order of things is also important. When we are running loops within methods, which will often happen in our code, if we want the whole method to end instead of just the loop to end, we can return a value from the method. Just like when we learned about methods the first time, returning something from the method will instantly end the method. It will return the value and nothing else inside that method is going to happen. So just like before, we need to make sure we're returning the same type of value as we put in the method signature. And if the return type of the method is void, we can just put return and then a semicolon. And if there's no value after the return, that's okay, because we wanted to return nothing anyways. So let's look at an example of this. I've got a password method. In both of them, I'm doing some input. I've got a password variable. I'm saying while true. I'm asking the user for a password. I'm doing some input. If the password equals the word strong in leet speak, I guess, then I'm either going to return or I'm going to break. If I didn't return or if I didn't break, we're going to print weak and jump back up and ask them for another password. And then after the loop is over, we print good. When we are using a return, just keep in mind this line of code will never run because it's impossible for us to exit this loop without returning, which is going to exit our method completely. Sometimes this is useful. Sometimes we would rather use a break. It all depends on our use case. So let's fix that sum method from the beginning of the lesson. Here's the steps that we want to take. We want to ask the user for how many numbers they want. We want to keep track of our count, how many numbers we've asked for thus far, and our total of all of our numbers that we've collected so far. We want to make a loop that's going to loop the correct number of times. Ask the user for a new number, add that number to our total, increase the counter, and lastly, we're going to return the total. So, step 1, that one's pretty easy. We've got our method declaration, and we've got our new scanner variable. We're asking for a number of numbers, and we're getting an int to find how many total numbers they want. For my count and my total, what type of variables should those be? Those should both be integers. And what should I initialize them to? How many numbers have I asked for thus far? At this point in my program, how many numbers out of my total numbers have I asked for? So if I want, in my loop, I'm going to ask for total numbers, number of numbers. So I'm going to ask for, if they input 5 here, I'm going to ask for 5 numbers. Have I asked for any of those 5 numbers yet? We have not. So we're going to start that at 0. And for our total, have we added any numbers to our total yet? Nope. So that's also going to start at 0. So it count 0, in total also 0. If I want to make a loop that's going to go the right number of times, we're going to use a while loop. What should the condition for our while loop be?
Greater than total number.
Do we want count to be greater than total numbers?
Sorry.
So you're right that we want to compare count and total numbers. So count. So I want to keep looping as long as I have not asked for the total number of numbers, right?
Yeah.
So what will count be when I have not asked for all the numbers yet?
0.
No, it won't stay as 0. Each time I ask for a number, I'm going to increase by 1, right? So what will count be when I've asked for 3 numbers? 3. Should be 3. If I want 5 total numbers, have I asked for all the numbers yet? No. So will count be greater than, less than, equal to my total numbers?
Less than or equal to.
I think we want to have less than because we're going to start at 0. So while my count is less than my total number of numbers, while I have not asked for my total number of numbers, we're going to keep looping. So while my count is less than those numbers, we're going to ask the user for a number. So print, and we're going to get a number from the user. How do I add that number to my total? What do I have to do to update this variable with that new value?
Total plus or total plus equals.
Total plus equals none. Absolutely correct. So we're going to update our total. We're going to add num and overwrite our total variable with that new value. And we want to increase our count by 1. So I can use my plus plus operator and just say count plus plus, increasing the count by 1. And this will loop until I have asked for all of my inputs. And our last step is going to be returning the total. So we need to close our while loop, curly braces. After the loop is finished, we're going to return our total. And we also need to make sure we close our brackets for the method itself. So let's look at this code running. I have programmed it. I've copied and pasted it into a sandbox. If my computer will, there we go. So I have that same code here. Let's run it. How many numbers do we want to input? Someone give me a number. Any number. 3. And I'm going to input 3 numbers. 8, 3, 2. 8 plus 2 is 12. Wow. 8 plus 2 is 10. 10 plus 3 is 13. So we get the correct number of numbers. We are calling sum from our main, and we are printing the result. Does this concept make sense? Cool? Sweet. All right.